In the previous videos, we used implicit differentiation to find the y prime, that is the change in y over the change in x. So the instantaneous rate of change. Well, in the next couple of problems, we're going to use the derivative to find the tangent line at a given point. Let's do this first with the circle of radius 3. It turns out one of the points on a circle of radius 3 is this one, 3 root 3 over 2, comma, 3 over 2. So let's use implicit differentiation to find the tangent line at that point. Earlier, we found the derivative of the circle of radius 3. We found the y prime there. We're going to do that once again, just for completeness of this problem. So derivative of the left-hand side would be 2x to the first plus 2y multiplied times y prime. And then the derivative of the right-hand side is equal to 0. So again, I obtain that by taking the derivative of both sides. We can solve for y prime. One way to do that is to subtract 2x from both sides. That would leave us with 2y times y prime equal to negative 2x. Then divide both sides by 2y. Y prime would be equal to negative 2x divided by 2y. We can cancel out those 2's if we want, and we just get a y prime, which is negative x over y. So this equation gives me the instantaneous rate of change at a given point. So the instantaneous rate of change at this point here can be obtained by just plugging that point in to my y prime equation. So we have y prime is equal to negative x over y. In this scenario, my x value is 3 root 3 over 2. And my y value for this point is 3 over 2. So I plug in my x value on top, I plug in my y value on bottom, and then I would simplify. I'll do that in a short fashion. We would end up with y prime equals the square root of 3. The 3's cancel out, the 2's cancel out. You'd end up with, you'd end up with negative square root of 3. So y prime equals negative square root of 3. Now that's the slope of the tangent line. We want to find the actual tangent line. So we know a tangent line has an equation y equals mx plus b. We just found that the instantaneous rate of change is negative root 3. So that means my slope has to be negative square root of 3. So my tangent line is going to be of the form y equals square root of 3 times x plus b. The way I find b is I plug in the values for this point here into my x and y. So the 3 root 3 over 2, that is going to be plugged in for my x. And this 3 over 2 is going to be plugged in for my y. So we're going to get 3 over 2 equals negative square root of 3. So negative square root of 3 times an x value, which is 3 root 3 over 2 plus b. And now I can solve for b. So the left-hand side stays as 3/2. The right-hand side of that equation is going to turn into a negative 9/2 plus b. If I add 9/2 to both sides, I end up with 12/2 is equal to b, which means b has to be 6. So my equation of the tangent line is going to be y equals negative square root of 3x plus 6. Let's see how that line matches up and meshes with the graph at this value here. What I've done is I've went on Desmos and I've created the circle of radius 3, and you can see the point on the circle of radius 3 is the point 3 root 3 over 2, comma, 3/2. If we had a tangent line, it's going to go in that direction. It's going to go so that it only hits the circle at this single point. And we are saying that the tangent line should be y equals negative square root of 3 times x plus 6. Notice that that line does exactly what we want. It goes and touches that circle at that point and then keeps going. So that is the tangent line at that particular point on the circle. Now, we could have found the tangent line at any point on the circle. I just happened to choose 3 root 3 over 2, comma, 3 over 2. But at any point on the circle, you're going to be able to find the tangent line by going through that same method. Let's do another example. We're going to use implicit differentiation to find the y prime, the change in y over change in x. And then we're going to use that to find the tangent line at the given point on this equation. So this equation is x squared times y to the third minus 2x to the fourth y squared equals negative 196. And we're looking at the point 2, 7. If you plug in 2 into the x value and 7 into the y value, you should see that this does give you a true statement. So we know the point 2, 7 is on the graph of whatever this thing looks like. Okay, the first thing we have to do is look at this equation and take the derivative of both sides. Now you'll notice that we have 2 pieces in here. And each of those pieces, each of those terms needs to have both a product rule and a chain rule applied when taking the derivative. So if I focus in on x squared times y to the third, that's actually a product rule where the x squared is like an f and the y to the third is like a g. So I would take the derivative of f, that's 2x, times normal g, which is y to the third, plus the normal f, x squared is the normal f, times the derivative of y to the third, the derivative of g. So that would be 3y squared. And then I'm multiplying by the inside function, which is y, of the derivative of the inside function, which is y prime. So all of that just came out of this first term here. So all of this came from a product rule on that first term. Now we're going to subtract, and we're going to have to take a product rule on this second term. So it's going to go very similar. We're going to let the 2x to the fourth be my f, and my y squared be my g. So derivative of f would be 8x to the third times normal g, that's y squared, plus normal f to x to the fourth, multiplied times the derivative of y squared. Well, derivative of y squared is 2y times the derivative of the inside function, which is y prime. When I take the derivative of negative 196, because that's a constant, I just get 0. So what we get here is a big, long equation. It's all right, though. We can deal with it. I'm going to clean this up a little bit. 2xy to the third plus x squared y squared times 3. Then we multiply that by y prime. Now I'm going to distribute this negative sign. So that is negative 8x to the third y squared minus 4x to the fourth y times y prime. And that's all set equal to 0. Solving for y prime means that I need to get all the y prime terms on one side and all of the non-y prime terms on the other. That would mean we're going to keep the y prime terms on the left-hand side. You can see 3x squared y squared times y prime has a y prime on it. This minus 4x to the fourth y times y prime also has a y prime on it. I'll subtract 2xy to the third from both sides. And then I will add 8x to the third y squared to both sides. From here, we need to factor out a y prime from both terms on the left, and then divide by the coefficient. So factor out that y prime. You can either factor it out in the front or behind, either way. And then, about time, we get explicit definition for y prime. Y prime is going to be negative 2xy to the third plus 8x to the third y squared. And all of that is going to be divided by 3x squared y squared minus 4x to the fourth y. Now that's a big, ugly expression, but we can still deal with it. Remember, we were trying to find the tangent line at the point 2,7. So first, let's look at the instantaneous rate of change. At the point 2,7. This means I just plug in a 2 every time I see an x and a 7 every time I see a y. So it's going to be this negative 2 times 2 multiplied times 7 to the third plus 8 times 2 to the third times 7 squared. And then we plug in on the bottom a 2 every time I see an x and a 7 every time I see a y. Let's go ahead and calculate that. When I calculate that, I ended up with a y prime, which was 1764 divided by 140. And that is roughly 12.6. In fact, it's exactly 12.6. I hope that's what you got, because now we're going to move on and find the tangent line at the point 27. The line is going to be y equals mx plus b. Now that I know at that point we have an instantaneous rate of change of 12.6, I know my slope is going to be 12.6 at that point. We write that in for my m. And then we can find b by plugging in 7 for y and 2 for x, because remember, this line has to go through the point 27. So we calculate that, 7 minus 12.6 times 2 becomes negative 18.2. So when you multiply this and then subtract it from both sides, you get a b value, which is negative 18.2. We have the slope, we have the b value, therefore we know the tangent line. Tangent line is the line y equals 12.6x minus 18.2. So that's the tangent line at the point 27. That took me a minute to actually find the using implicit differentiation. That took me a minute to find the derivative. But once we have it, it's a fairly straightforward process to say what's the instantaneous rate of change at that point. Well, that's what y prime is telling you. And then understanding that that instant rate of change is the slope of the tangent line. So what I would like you to do is to try this problem on your own. It's going to be a pretty messy thing because we have 3 terms, which are all going to require a product rule and a chain rule inside of a product rule. But go ahead and try that on your own. Push pause on the video, and then on the next video, I'll explain how to solve this.